Okay, sorry for the delay. You can all blame it on Steve Jobs or Tim Cook. That's Apple, not my fault. Um, do you remember where you were on the 20th of February 2017? Or perhaps where you were on the 25th of November 2020? So actually, I do remember, and I assume you actually also do, because if you've been using cloud services, these were both days of very bad outages, which we had within AWS. The first one was the S3 outage of 2017. And this actually, the public message at the bottom, if you would like to read exactly the root cause and the postmortem from this outage, very detailed state of events, was because of some of the S3 engineers that were trying to solve a billing problem in S3, nothing to do with the service. They were trying to get their metrics were not coming fast enough, and their resolution was to, in this case, take down a number of back-end servers which were providing part of the service. And by mistake, the number of servers that were pulled down was significantly higher than what was supposed to be, and this kind of caused an outage. And this outage went on, and not only affected S3, it affected a number of other services, EC2, Lambda, EBS, the personal health dashboard. Pretty much the internet stopped that day because everybody was using everything going through S3 on US East 1. Clicker? Clicker's not working? This one was another outage. It was actually the weekend before reInvent. I wasn't there in Vegas at a specific time because it was, I think, my first or second year in AWS, and I didn't have the reason to be there. But this was a problem with Kinesis. Kinesis is a platform for streaming data or logs or whatever metrics you would like to do. And in this case, the engineers were making a change in the front end, and they brought on a number of, not removing servers, they actually added servers, which had a bad configuration, which caused a huge problem and a cascading failure in the cache mechanism, which kind of also brought down a good part of the internet for the day. The reason I'm telling you all about these things is not because AWS is bad or we had failures, everybody has failures, but the thing is, what I would like to talk about today is part of the fact of chaos engineering. And this is a quote from Werner Vogels, our CTO of Amazon.com, that says, "You need to build systems that can embrace failure. Failure is a good thing. Failure is something which you can use to improve your systems." And specifically for the two examples that I brought before, where I assume that the people that woke up that day on the EC2 teams or the Lambda teams or the ECS or EKS teams or a number of other service teams, or pretty much the whole of AWS that day, was not thinking that it was going to be a day where everything was going to be on fire, because they were relying on another service. They have dependencies. And in this case, containers is pretty much where we run our applications today, if not in Lambda from the previous session. That also can be done running containers. That's a different story. But there are dependencies which we have to also think about when we're running our containers as well. Not only the actual container or whatever we package inside, but there are underlying dependencies, and this is what this talk is going to be about. My name is Maish. I'm a developer advocate for the ECS service team. That means I work with the systems engineers and the product managers, and every now and again I get to go to conferences and get on stage like this to speak. I'm located out of Israel, so thank you, Brussels. Thank you, Louvel. I also kind of speak Dutch, so that's okay. So that might be a bit of a difference. And this is a quote from Principles of Chaos. I'll let you read it while I'm speaking, but anyway, essentially what this says: break things on purpose. And I'm going to add in break things often on purpose in order for you to understand where your weak points are, so you can fix them and make your systems more resilient. So what are we going to be doing today? The first thing I want to do is what we're not going to be covering. Then we'll talk a little bit about health checks, and then underlying dependencies, tooling, and pretty much that will sum up my talk for today. I do notice that the time on the screen is not correct, but that doesn't really make a difference because I'm going to ignore it anyway. So, So what are we not talking about today? I think that as an industry, we're pretty much at a place that we can say we trust the orchestrators that we're using are going to do their job. It doesn't make a difference if it's Kubernetes native, ECS, EKS, Nomad, Mesos. It makes absolutely no difference. We have orchestrators which are at a mature state that will do what we want them to do. We want them to deploy containers. We want them to scale up containers. We want them to scale them down, replace bad pods or tasks. They do what they're supposed to do. That's why I'm not going to be talking how to configure Kubernetes or ECS or any of the other solutions today, because besides the fact that you can get them today as managed services, there's more than enough tooling today out around, everywhere around the world, that you can use in order to do that properly. And if you're not, you should adopt those solutions today as much as possible. What I am going to be talking about today was the first thing is health checks. So, what is a health check? A health check is a simple question. Essentially, is the service that I'm providing doing its job, or isn't it? The problem is, how do you get to that answer? Usually you have a load balancer which will pull your application to see if it's passing a health check, and if so, it will put it into service, and if it's not, then it will take it out of service and no longer route traffic to that application. But not necessarily when you're doing these health checks, are you getting the right information? And in many, many cases, you can get a lot of false positives, which can cause a lot of problems. So let's have a look at different kinds of checks that we have today, and we also use them today in Amazon. First one is a liveness check. A liveness check is a pretty simple, basic check. And usually this is very low level at the container level, which says, is my process running? And is it listening to the port or providing a response code that I expected? A 200 code, okay. If the process is running, then the container is started. That's fine. And unfortunately, it doesn't really give you very much information, because there could be a number of underlying dependencies, which we spoke about before. As we said, EC2 depended on S3, which depended on a number of other services as well. That might not be working. So there's another kind of check, which is called a local health check. A local health check tells me if the application is actually available or capable of doing its job. Not necessarily if the process is started, or if it's serving traffic, but rather if it is able to read or write to the disk. And no matter how much you tell me that stateful applications don't need disk or persistent data, a container still needs a disk to write and read information to. Are the processes which are in the background running, are the supporting resources which are supposed to be running on my application, be it a logging daemon or a logging process or a security process or a networking metric process, all of those things I need to know that my application and my container is actually running or doing its job. Otherwise, I'm kind of flying blind. I can't get the information I want out of my containers. Going down, as we say, dependencies, this is a pretty much kind of comprehensive health check, where essentially you have, for example, if we take an example of an Nginx container, I'm going to not only check if the Nginx process is up and running, if the configuration can read from its disk, can write from its disk, write the logs, send the metrics, but I'm also going to actually check if the backend of my Nginx is actually working and I can reach my dependency peers. If I can reach my database, if I have credentials which are valid and not stale on my applications so that it can actually perform its position. These are the health checks that you would like to get to. They're not always easy. And as a reason, because I was talking about the fact of false positives, you can't verify that the problem is lying with you in the container. Because you can try to reach the database, but if the data in the database is corrupted or there is a permissions problem in the database, there's nothing you as the container can do anything about it. So it will report an error. So what do? Do you restart your container? Do you do other things? What kind of resources would you do for that kind of a problem? These are things with the false positives, which you have dependencies on the back end underneath you. You have to think about in order for you to understand what you can actually use with that information in your health check itself. The last kind of health check I would like to talk about is anomaly detection, and we're going to talk a little bit about further this when we're talking about the actual the chaos engineering or testing we can do, is we all expect our applications and containers to do their job. And usually they do. And every now and again, there might be 1 or 2 or 50 pods or tasks or containers running in my pods that got a wonky kind of configuration and are doing something weird, and therefore I'm not getting consistent results. So are there outliers? For example, if one of the containers has a problem synchronizing its time, and therefore cannot synchronize correct credentials, and the credentials have timed out because there's a skew in between my clocks, I would like to know from an application perspective, have I got an outlier which can cause a problem? And then I need to know what I need to do with that. Outliers can be from, I say, clocks. It can be the fact of, is it behaving in a way which is not usual? These are things that you have to measure over time, how your application is profiled, how it's supposed to work. And as a result, you can start recognizing those outliers where things are not working correctly. So let's talk about the underlying container dependencies. And the usual suspects, if you know the movie. If not, go watch it. It's a nice film. Kaiser Soze was an awesome villain in the movie. They are the usual suspects, and we're talking about CPU, memory, disk, and I/O. The question is, where are these CPU, memory, and disk, and I/O, which you should be testing for, running your chaos experiments on, and understanding how you can implement a chaos engineering strategy in order to make your applications better. So, CPU. I said before, we're pretty much not going to be talking about Kubernetes or Mesos or ECS, whatever it may be, because they are pretty much doing what they're supposed to be doing today. And as a result, I'm pretty sure that when you request resources for your container, your application, your pod, your task, when you want one virtual CPU and that amount of memory reservation or CPU reservation or CPU limits, the system behind you, which is provisioning all those things, will do its job. That's what you're going to get. So I don't have to test for this specific case for CPU stressing what is happening on the underlying instance, but I do have to test inside my actual task. What is going to happen when I start stressing my container? How is it going to behave? Will it be able to provide functionality? Will it start throwing errors? Will my logs continue to flow because the CPU is starved and the other process which is running inside the container is not able to write your logs? By running a CPU stress inside your container itself will give you a lot of information to tell you how your application behaves when things go wrong. As we said with CPU, Kubernetes or ECS will provide the amount of memory you have reserved or limited for your application. So again, I'm not going to look at the fact of how I'm relying on the underlying platform and the operating system to give me my slice of memory. But inside my pod or my application, my container, what happens when I start running out of memory? Java out of memory errors. What will happen to my next application? How do I need to respond based on that actual check when I'm starting to stress to see if my application starts running out of memory because of a leak in the code or something else? Will, again, the other underlying processes be able to perform? Will I be able to write logs? Will I be able to send metrics? And if it restarts, how long it will take for me to recover? Because, as we said, it restarts. If we're pretty much, as I said, at the stage that restarting pods or restarting unhealthy containers inside my services is a relatively instantaneous thing today. But some things need to warm up caches in the background, so you have to understand how your behavior of your application actually works for running your chaos experiments. Whenever there's a problem, it's always the network, unless it's DNS or the network. But I'm an infrastructure person, or I used to be an infrastructure person before many, many years ago. I haven't touched the physical server in 7, 8, 10 years almost, but that's a different story. When we're talking about network, I think I can say we're at a stage where we cannot rely on the underlying infrastructure to provide us consistent network. In other words, there's no way to set network shares and network limit All network policies today and currently in Kubernetes are the fact of security. What container or pod can talk to the other, not how much gigabytes or gigabit throughput I get from my specific container. So in this case, number one, you have to check in both places, also in the underlying infrastructure, on your hosts, and also in your containers. What happens when you start getting slowness in your network, ingesting latency into your applications? How will this affect? Will your application start to work slower? Will it start to throw errors? It will time out. If it times out, how will it retry? These are things, by injecting latency into your applications at multiple levels, will give you an insight of how your application performs and what needs to be changed if something breaks. I used to crimp my own cables a long time ago. I still do every now and again when I have a very specific length when I want to get to something in my wall in my home office, but I don't usually. I go and buy things because of small breaks in cables, which can cause packet loss. And again, this is something you're going to be testing at both levels, also at your container level and also at your host level as well, because there's no guarantees from the network underlying infrastructure. And usually when you talk about packet losses, it's usually a problem of either bad cabling in the actual network infrastructure or what we call flipped bits. In other words, something happened, and it happens once every million or billion packets or operations, that something flips in the actual network card underlying and starts causing problems by feeding garbage to the network. But when you operate at scale, once in a million, or once in a billion, or once in 100 billion, can happen once every hour. And this will start causing issues for your applications. So inject packet loss as well, also into your applications to understand how they're going to behave. Will the application retry? Will it be able to do some kind of backoff if I need it to, in order to not overload and overrun my underlying resources and services and dependencies? Infinite black hole, when finally something gets dropped off the network, either the host or the containers. I think from this perspective, we'll understand that the container orchestration system will restart or respawn instances instead because it no longer has access to your service check. But what happens when they come back up? How will your application behave? Will it be able to understand that it should no longer be serving traffic if it was off for a certain amount of time? Is there code which is stale inside that container, or credentials which are stale? And if it has been buffering information inside, will it not cause a thundering herd syndrome or concept, whatever you say, when you fact is you're standing in the middle of the field and you just see everything coming straight at you and you don't know what to do with it? That's what will happen with the underlying services, by just flooding it with information and causing a cascading failure. Packet loss, we said, and this is also the fact of disconnects as well. So black holing some kind of a network information, for example, you drop out a whole AZ, how will your application behave? Will you be able to recover? Do you have enough infrastructure underneath in order to scale up your physical hosts or your containers underneath in order for that to work? So you've run through these chaos experiments, you've tested these different things, but now what do you do? How often do you do this? What do you do with this information? And in Amazon, we have I would say, concept what we call the flywheel. Flywheel is in every team has their own flywheel, and every service has their own flywheel. And the fact is we have a circular motion of things where we continuously do things in order to improve. And I'm going to start at the top right-hand side of you with the fact of preparing. So for everything, please, if there's one thing you take out from this talk, think about what you're doing before. Don't start running chaos experiments on things in your production systems without planning what you might do and what kind of outage you might cause. Run through a scenario of what you're going to be doing, what you want to test. The preparations phase is the fact is describing a scenario, what we're going to be testing, what I expect to receive from my systems currently today. Will I get the alerts? Will I get the right people engaged? Start running the experiment. And then we go to the detect phase. Did I get the actual artifacts which I was expecting? Were the right people pulled into the room? Did I have all the metrics I needed? Did I have all the information and logs that I needed? If not, document them so you can see how you can improve this further around the way. The next part is to the response. You had the outage. What did I do to recover from that outage in the shortest time as possible? What did I need? Did I have the right people in the room? Did I have the right tooling? Did I have the right response or operational playbooks in my background in order for me to do this? If so, these things should be documented. If not, you go to the learn phase and you understand where your gaps were, what was missing, and then you continuously improve and run this again and again and again and again. This is how you improve on a regular basis. Run these often, run these frequently. And there's a concept of game days, which I'm sure pretty much all of you are already very much aware of. And these are awesome things to do if you have the time and you're not putting out fires. But it is an important thing to actually invest the time in order to do these game days and these kind of processes in order to make your systems more and more resilient. And what we want in the end eventually is what we say, the shorter and less incidents. Nobody likes to get woken up at 3 o'clock in the morning on a Friday when they're skiing in the middle of the Alps in the middle of the winter because something happened at their application at work. So these kind of mechanisms is an investment for you, for your future, in order for you to reduce the number of incidents and fatigue from managing your systems. Tooling to accomplish this? Well, there's Chaos Monkey, which is Netflix, and they wrote a tool for them to start messing up, letting a little monkey around in their systems to start pulling plugs, essentially. A lot of it's based on AWS. So there was Chaos Monkey, Chaos Gorilla, Chaos Kong, which would bring down a whole region of services. I don't know if they still exist because I haven't used it for quite a while. There are third-party tools, commercial tools like Gremlin, Chaos Engineering. It's a very comprehensive tool which will allow you to run these kind of experiments and provide a central framework behind it as well. And if you want to use something which is native to AWS, we have something called Amazon Fault Injection Simulator, which is this managed service, which allows you to provide these scenarios and experiments in a secure, managed, controlled way that you can run these things in the way as you want on all your resources within AWS. I will caveat the things that many of the things today, which I spoke about of injecting latency and things like that, is not currently available for container services, ECS and EKS, but it will be shortly. So you don't have to wait very long for that, but it will be there. But there are other ways you can check your applications as well. So I want to go back to the learn phase. Have any of you heard of a COE? Yeah. COE is a correction of errors. So we have a process inside Amazon where we use a mechanism, and mechanism is a tool which many of the other teams can use to learn from our problems. Provide an owner which will actually dive deep into this actual issue which we had, and document these lessons, and hopefully prevent this from occurring specifically in that service, but also share knowledge to a number of other services within AWS and Amazon. It is not a blame game. Nobody gets personally blamed because that's not what we're there for, and it's not a punishment for anybody else. Nobody gets a slap on the wrist because their service went down. That is not the way we operate, and I implore you all to do the same thing, because that causes a toxic environment inside your organization where people are afraid to do things because they might get blamed for it. Rather, do it in the fact of a learning experience, an improvement option that will allow you to grow as your organization. So when do we use, or when should you use, also when do we use, I'll put it this way, it's up to you, you can use this. When do we use a COE? So whenever there was a customer impacting event, when something happened that a customer reported an error or multiple customers reported an error, when, for example, we were running a game day or a chaos engineering and we missed a certain number of test cases. For example, we were expecting the metrics to give us information or the logs, and they didn't. That is something which we need to improve and fix. When something completely else happened and had a dependency on an underlying service, we didn't even think about that. That's a missed use case. Or when we do something which can prevent an opportunity for another team to improve as well. It's what we call these wins. In other words, one of the teams found a specific thing, for example, reduced the compression algorithm on all the S3 and saved hundreds of petabytes of storage because they moved to a different storage algorithm or compression algorithm. Is something that other teams can also use and also save money. So these are the kinds of things where it will present an opportunity of improvement for other teams as well in the rest of the organization. So what does the COE look like? The first is the supporting information. What actually happened? So that boils down to, firstly, the impact. And the impact is not that my Apache service restarted or I lost 30% of my pods. The impact was that my customer was not able to purchase, or 300,000 customers were not able to purchase or deposit money in their account because my application was down. That is the impact of what actually happened to your service. Don't really care what the technology details underneath it, what is the customer-facing impact of the outage. A detailed timeline. When it happened, when we detected it, what we did at what time in order to fix it, and how long, all those things, so you can document all those things in order for you to understand how the process went, and also improve on that. For example, why it took us 5 minutes to realize that there was a problem. How could we have fixed those kind of things in order to reduce that amount of time? Which comes into the incident questions. We'll get there in a second. Metrics. A graph is better than 1,000 words or any kind of number of documents that you can write. When you can see, and that will also provide you the fact of having the correct health checks and metrics involved, that you're going to actually see what happened with your service and what the impact was, and visually present it to the people which are going over this document. And the last is, what was the incident questions that we had? For example, when did we recognize the problem? What did we do? Who were the people that were involved? What steps did they take? What worked? How did they debug the problem? How did they find the root cause? How did they fix the problem? All these questions we can have in order to document the process. This takes a certain amount of responsibility and maturity in order for you to do this and not say, okay, I'm going to fire all pistons in all directions in order to try and fix something. But yes, you do need to document these things in order for you to understand how you can fix them and go further with your journey. That's the supporting information. The second part is the corrections. These are the learning and the action from each and every single document. And the interesting thing is, in Amazon, we have a meeting once a week with, I would say, pretty much up till VP of engineering or VP of infrastructure, very, very people which have got a lot better things to do, besides sitting for 2 hours in a meeting to go over all these different errors which happened in infrastructure over the past 2 weeks, or the past week, and all the wins, and all the different kind of things which we have, in order, because it's extremely important, not only to the people which are writing the code, it's also important for them to understand how, as a big organization, you can improve. So the corrections will be the 5 whys. So if we take my example of my web server container stopped, why? Because somebody pushed a bad configuration. But why did they push bad configuration? Because nobody did a two-peer review on my application before they pushed the code config. And why didn't they do that? Because the team has been awake for the past 48 hours trying to solve another problem, and nobody had the puff to go and read the code properly. They were all completely overworked, overstressed, and this wasn't something which was that they wanted to check. And why was that the problem? Continue asking yourself in order to get to the actual reason. And the reason was they were understaffed. That's why this actual issue happened. So you can fix that by hiring more people, shedding load, improving your processes in order to do these things automatically without giving all the overhead on the actual people. But dive further and further and further and further as far as you can go to understand what was the actual reason of this was happening. It doesn't have to be 5 times. It can be more if you want. Usually it's minimum of 5. But dive into that process to understand the actual underlying root cause of what was the issue. The next thing is action items. What are the team, and again, it's a team effort. It's not one person's problem and not one person's responsibility or fault. What did the team take as action items to learn from this. The fact, for example, if we go back into my 5 whys, the fact of we're going to try and reduce the number of tickets we're getting over the next 6 months in order to make the team health better. We're going to ensure in code that nobody can push a configuration change without actually getting 2 manual approvals from somebody else. These are all things that you can add into your processes to make your systems more resilient. And the last thing is related items where you can refer to different other outages which were similar, if you learn from them in certain ways, those kind of things and references. And the last thing which you actually do, which is actually the first item on the list, is you write a summary. Summary should be the last thing you write. An executive summary, 1 paragraph of this happened, this is what we did, this is how we recovered, this is what we learned. In order for that to get to your summary, you have to go through all the other steps first. This is how we usually do a COE. It's a process which I love. Personally, I'm lucky enough never to have been as part of a service team which actually had to go through this process. But it's fascinating about how things fail on a regular basis, even in companies like Amazon on a regular basis, because distributed systems are hard and complex, and there's nothing you can do about that. Things happen. I finished a little early, but that's okay. Give you some time to get a coffee or a drink. A couple of additional resources. The first one is a link to the AWS Builders Library. If you're not aware of the AWS Builders Library, it is a set of white papers where our principal engineers, I would say, pontificate or give very good guidance of how we do things in Amazon, how we build distributed systems, how we build exponential backup for our applications, how we do CI/CD in very large environments. One of them, of course, is how we build health checks as well. A lot of the information which I gave you today came from that actual white paper. That one links specifically to the fact of implementing health checks, but I do advise you there's extremely valuable information. It doesn't give you the exact building blocks and step by step of how to do these things, because that's not what these papers are for. But it can give you enough insight of how you can actually implement these things inside your organization. Second one is a practical lab where you can go through from the AWS well-architected lab for implementing these health checks if you want to try it out on your own account. Self-service, you can do it whenever you want. You pay for the resources, it'll tell you how to clean up the resources when you're done. Good resource. The third one is the fault injection simulator. That's the link to the product, if you would like to look at it. The last one is a link to the Principles of Chaos website. And on the screen is a QR code. Please do me a favor, scan it for a second. It's to provide feedback from all of you for the session. It's very important to me to understand how the session was, if it was valuable for you, if you found it useful, is there anything that can be improved, anything that should be changed. So do me a favor and please take a snapshot of the screen. I would very, very much appreciate if you give me the feedback from the session. My name is Maish Saidel-Keesing. My email and Twitter handle are here up on the screen. If you want to ask me anything about containers, chaos engineering, CI/CD, DevOps, the world, Judaism, whatever you would like, I'm here. I will be here at the conference pretty much for the rest of the day. Please feel free to come over. Happy to meet and talk, and thank you very much for joining. If you have any questions, I'm here around. We've got some time, so if you want to ask out loud, I'm also. Yeah.
Wondering how far do you feel you should go with chaos engineering in general? Should you always go up into including full-on production systems, or should you keep it on lower levels, maybe like development or acceptance?
Okay. So I'll repeat the question for those that didn't hear. How far deep down or how far deep into your infrastructure should you go? All the way to production, or only keep it on staging or testing, whatever? As a person who has managed live systems and video systems in my previous life for a very long time and part of an SRE team, no matter how much you think your testing and staging environments are the same as your live production environments, they never are. So you will always have those outliers of having something which is slightly different in production. And I tested it in staging, but I didn't know what would happen in production because it was different. I think the goal is to run these things in a controlled manner, after you've got to a stage of being mature and understand that if you do cause a problem, one of the things, it won't actually cause an outage, or you can run it on a segment of your production system, not on the full-blown thing. That's what we have. In AWS, we have a concept called one box. One box is essentially one server, which includes the whole environment, for example, for one of the services. So you can run it on that one single instance, test the full in a production system. It doesn't necessarily have a lot of production traffic running into it, but it does provide this proper APIs. So there, if you can, get to production as much as possible, because otherwise you'll never have a proper 100% view into your actual what's happening itself. There was another question somewhere else behind, or not? Yeah. Okay. So the question was, when we create these COEs, how do we use them? So firstly, it is part of that weekly meeting where all the way up to pretty much senior management goes over all of these different outages that we have, and all the principal engineers and all the senior principal engineers, which have been around in the industry for a good number of years and know what they're talking about, it's a document, essentially, with everything that happened, the timeline, the metrics, the 5 whys, all those pieces are inside the document, and everybody reads and provides feedback of did the actions and lessons learned provide a solution in order for us to fix these problems, specifically in that error, that area of error that happened, and if we can also use this for other places as well. So this is something which is discussed every single week for 2 hours on a weekly basis, besides the people which are actually writing all these documents in the background. But there's a whole group of people of more than 100 or a couple of hundred people which are on the call and go through these documents to learn, to see if the team addressed the actual problems, and if not, come back with a newer version of the document in order for those things. It's a living document where everybody can access. We have a meeting on a regular basis to go over these things, because if just somebody writes it and nobody looks at it, it won't do anything. So people have to be accountable, understand what the action items are, how they're going to follow up, give them a due date when it's going to be fixed, and if everything was followed. And there's an owner, essentially there's somebody which actually owns the whole process, and they're the one which are responsible to make sure that everything happens. Any other questions? Awesome. Thank you very much.